Welcome, weary traveler, to a quiet corner of the cosmos, a place where the universe whispers its secrets and the gentle hum of discovery lulls you into a peaceful slumber. Here, with the sleepy scientist, we don't rush through the wonders of the world. Instead, we invite them in, softly, allowing their grandeur to unfurl like a calming dream. Tonight, as you settle in, perhaps nestling deeper into your pillow or letting your eyes gently drift closed, we're going to embark on a journey that delves into the very fabric of existence, exploring a concept that gives everything you touch its very essence of being: the God particle. Is it really the key to the universe? It's a question that whispers of the smallest building blocks, the deepest mysteries of reality, and the profound weight of all things. As you relax, let your thoughts drift. Much like the unseen fields that permeate all of space, imagine the solid ground beneath you, the gentle weight of your blanket, the firmness of your pillow. Everything around you has a certain heft, a solidity, a mass. But why? What gives matter its substance, its inertia, its resistance to being moved? It's a breathtaking thought, isn't it? And it's this very mystery that prompts our gentle inquiry tonight. We won't rush to the answers. Instead, we'll explore them with the same slow, deliberate pace that light itself travels across vast distances. This isn't about memorizing facts. It's about understanding, about feeling the profound elegance of the universe's most fundamental workings, and letting that understanding guide you towards a truly restful state. So, breathe deeply, let your muscles soften, and prepare to unravel one of the most fundamental riddles of our physical world. Not with effort, but with quiet curiosity. Our story, like many great scientific tales, begins with a deep dive into the very early moments of our universe, long before stars and galaxies, even before atoms as we know them. Imagine the cosmos right after the Big Bang, a period of unimaginable heat and density, when the universe was less than a tiny fraction of a second old. In this primordial soup, everything was fundamentally different from what we experience today. At that incredibly early stage, the universe was filled with elementary particles, the very smallest building blocks of matter and energy. Think of them as the alphabet of existence. These included particles that would eventually become electrons, quarks which make up protons and neutrons, and the particles that carry fundamental forces, like photons, particles of light. However, in this incredibly hot and energetic early universe, there was a profound difference from today. All of these elementary particles, the fundamental constituents of everything, had no mass. Imagine, if you will, a universe where everything is weightless. Without mass, particles would essentially fly around at the speed of light, unable to slow down or bind together. It would be a frictionless, insubstantial realm where nothing could truly stick. If electrons had no mass, they couldn't orbit atomic nuclei to form atoms. If quarks had no mass, they couldn't form protons and neutrons. Without stable protons and neutrons, there would be no atomic nuclei. And without atoms, there could be no molecules, no dust, no stars, no planets, and certainly no life. This early, massless universe would be a realm of pure energy and fleeting, insubstantial particles. It's a universe that, while fascinating to imagine, would be fundamentally incapable of forming the complex, structured cosmos we inhabit. For anything stable and substantial to emerge, for matter to coalesce into the gentle weight of a feather, the robust strength of a mountain, or the very substance of your hand, These elementary particles needed to acquire mass. The ability to have mass, to have heft, to have inertia, was the crucial missing ingredient for the universe to build anything beyond ephemeral energy. The big question, then, for physicists, was if these fundamental particles were born massless in the Big Bang. How did they eventually gain mass? What was the mechanism, the cosmic process, that conferred upon them the very quality that allows for the existence of everything around us? This was a profound riddle, a gaping hole in our understanding of how the universe transitioned from a state of pure energy to a state of substantial matter. Without an answer to this question, our understanding of why anything exists, why matter has weight, why stars can form, was incomplete. It was like having a magnificent blueprint for a building, but one crucial part of the foundation was missing, preventing the entire structure from ever being built. This mystery of mass was one of the most tantalizing challenges in fundamental physics for decades. It begged for a solution, a subtle, invisible mechanism that could explain the very solidity of existence. The answer, as we will gently discover, was eventually proposed as a groundbreaking theoretical concept, a new idea that would eventually lead to the hunt for something truly extraordinary. It was a hypothesis that suggested an entirely new kind of field permeating all of space, a field that would interact with particles and bestow upon them the very property of mass. Imagine, as you relax deeper, the universe right after its birth, a fleeting moment of pure, massless energy, everything racing at light speed. Picture the cosmic yearning for substance, for solidity, for something to hold things together. This quiet, yet profound contemplation of the universe's primordial state is the very first secret to understanding the God particle and its role in creation. It's a natural, ongoing process, a quiet testament to the universe's inherent design, holding within it the blueprint for all substance. Let the image of a massless universe, yearning for solidity, settle peacefully in your mind. This is the origin story of our search for the God particle, a journey that begins with the fundamental physics of our cosmic beginnings. Feel the quiet power of this hidden transformation, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of the early cosmos, carrying its timeless secrets, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler. As we continue our gentle exploration into the God particle, is it really the key to the universe? In our last quiet chapter, we journeyed into the universe's earliest moments, contemplating a time when all fundamental particles were massless, unable to form the solid structures of our cosmos. Now, as you drift even deeper into your serene state, let us introduce the elegant map that guides physicists in their quest to understand these tiny building blocks, the standard model of particle physics. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine a vast, cosmic, periodic table. Just as the periodic table organizes all the known chemical elements like hydrogen, oxygen, gold. The Standard Model is a groundbreaking scientific theory that organizes and describes all the known fundamental particles that make up matter, and the fundamental forces except gravity that govern their interactions. It's like a comprehensive instruction manual for the universe at its most microscopic level. Think of it as a beautifully intricate, yet incredibly successful puzzle that physicists have painstakingly assembled over decades. This model classifies all known elementary particles into two main families: fermions. These are the matter particles, the building blocks of everything you see and touch. Imagine them as the stuff of the universe. They include quarks. These are the tiny particles that combine to form protons and neutrons, which in turn make up the nuclei of atoms. There are 6 flavors of quarks, each with delightful names like up, down, charm, strange, top, and bottom, leptons. This family includes the familiar electron, which orbits atomic nuclei, and its heavier cousins, the muon and tau particle. It also includes the elusive neutrinos, tiny, almost massless particles that barely interact with anything, constantly streaming through you and the entire Earth unnoticed. Bosons. These are the force-carrying particles, the unseen messengers that mediate the fundamental forces of nature, gluing the universe together. Imagine them as the interactions between the stuff. They include photons. These are the particles of light, which carry the electromagnetic force responsible for light, electricity, and magnetism, gluons. These particles carry the strong nuclear force, the incredibly powerful force that binds quarks together to form protons and neutrons, and holds atomic nuclei together, and Z bosons. These particles carry the weak nuclear force, which is involved in radioactive decay and processes like nuclear fusion in the Sun. The Standard Model is a triumph of modern physics. It has been incredibly successful at explaining and predicting the behavior of these fundamental particles and their interactions with astonishing accuracy. Experiments conducted in colossal particle accelerators, like the Large Hadron Collider, have repeatedly confirmed its predictions with exquisite precision. It explains why atoms hold together, why certain elements undergo radioactive decay, and how light interacts with matter. It's a testament to humanity's ability to decipher the universe's deepest codes. Imagine the Standard Model as a grand cosmic symphony orchestra. Each particle is an instrument, and each force is a conductor guiding their interactions. This symphony plays out continuously at the smallest scales, creating the reality we experience. It has revealed a universe built from a surprisingly small number of fundamental pieces, interacting through a few elegant rules. However, despite its immense success, the Standard Model is not a complete picture of the universe. It's a truly remarkable map, but it has some important blank spaces, some profound questions it cannot answer. For instance, the Standard Model, in its original formulation, does not include gravity, the force that pulls apples to the ground and holds galaxies together. Scientists are still searching for a way to fully incorporate gravity into this quantum framework. It also doesn't explain the mysteries of dark matter or dark energy, those elusive components that make up the vast majority of the universe's mass and energy, but which we cannot directly see or interact with using the particles of the Standard Model. But for all its unanswered questions, the Standard Model provided the essential framework, the guiding principles, for understanding the tiny particles that possess mass and the interactions that allow them to form the world around us. It's a testament to the power of human intellect to build such a comprehensive and elegant description of reality at its most fundamental level. This incredible map is the very second secret to understanding the God particle and its role in revealing the universe's secrets. Imagine, as you relax deeper, this elegant Standard Model, silently organizing the invisible dance of quarks, leptons, and bosons within every atom, every cell, every star. Picture it as a whispered instruction manual, explaining the very essence of matter and force. This quiet, yet profound map of the very small is a testament to humanity's tireless quest to listen to the universe and unravel its deepest riddles. Let the image of the Standard Model, a beautiful and intricate diagram of the universe's smallest parts, settle peacefully in your mind. This is the enduring achievement of particle physics, a journey that begins with the fundamental quest to understand what everything is made of. Feel the quiet power of this unseen blueprint, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of the Standard Model, carrying its timeless secrets, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler. As we continue our gentle exploration into the God particle, is it really the key to the universe? In our last quiet chapter, we introduced the elegant map of fundamental particles and forces, the Standard Model of particle physics, and celebrated its incredible successes. Now, as you drift even deeper into your serene state, let us confront the one gaping hole, the central puzzle, that the Standard Model, in its original form, could not explain the profound mystery of mass itself. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine the universe as a grand, intricate ballet. We have all the dancers, the fundamental particles and the rules for their interactions, the fundamental forces. But there was a missing piece in the choreography, a fundamental question that simply didn't have an answer. Why do some particles have mass, while others do not? Think of the particles described by the Standard Model. We know that photons, the particles of light, have no mass. They constantly zip through the vacuum of space at the ultimate cosmic speed limit, the speed of light. This makes perfect sense according to the theory of relativity, where massless particles must travel at light speed. However, what about other fundamental particles, like the electron that orbits every atom, or the quarks that make up protons and neutrons? These particles clearly have mass. You can feel the mass of an electron when it flows as electricity, or the mass of protons and neutrons when they give substance to an atom. If they had no mass, they would also be flying around at the speed of light, unable to form stable atoms, molecules, or any solid structure. The problem for physicists was this: the equations of the Standard Model, in their most elegant and fundamental form, seem to predict that all elementary particles should be massless, just like photons. If you simply added mass to these equations by hand, the entire beautiful mathematical structure would collapse, leading to inconsistencies and breaking fundamental symmetries. It was like having a perfectly logical and beautiful story, but one character absolutely had to be present. And yet, according to the story's own rules, they shouldn't exist. This was a profound paradox. We clearly observe that electrons and quarks have mass. Otherwise, matter wouldn't exist as we know it. The very chair you're sitting on, the very air you breathe, the very essence of your body, all depend on particles having mass. But the most successful theory describing these particles couldn't explain how they acquired it. It was a gaping hole in our understanding, a crucial missing puzzle piece in the grand blueprint of the universe. Imagine a meticulously drawn map of a vast, unexplored territory. You have all the mountains, rivers, and cities charted with incredible detail. But then you realize there's a huge, blank space right in the middle, labeled "Here be dragons," or simply "Unknown." That blank space represented the mystery of mass in the Standard Model. It was a challenge that puzzled the brightest minds in physics for decades. How could a theory be so incredibly successful at describing the universe, yet fail at such a basic, fundamental level? This profound mystery wasn't just an abstract theoretical problem, it had immense practical implications. Without understanding the origin of mass, we couldn't truly understand why matter behaves the way it does, why atoms form, or why there's anything solid and substantial in the universe at all. It was the missing link in our understanding of how the universe transitioned from the early, massless Big Bang state to the structured, mass-filled cosmos we inhabit today. The search for this missing mechanism became one of the holy grails of particle physics. This puzzle forced physicists to propose new ideas, new mechanisms, to elegantly account for the mass of these fundamental particles without breaking the beautiful symmetries of the Standard Model. It was a testament to the scientific process itself. When a theory, no matter how successful, encounters a fundamental contradiction with observation, it must evolve. It must seek new explanations. It must propose new, unseen realities to fill the void. This profound question, this yearning to understand the origin of substance, eventually led a brilliant group of scientists to independently propose a revolutionary concept, a subtle yet pervasive influence that would eventually give particles their very heft. This missing piece, this elegant solution, would become the focus of a decades-long quest, culminating in one of the most celebrated scientific discoveries of our time. It was a search for the very mechanism that grants matter its weight, its inertia, its being. Imagine, as you relax deeper, this profound mystery of why things have weight, this central question that puzzled the universe's most brilliant minds. Picture the elegant equations of physics, yearning for completion, for a missing piece that would finally explain the very solidity of existence. This quiet, yet profound puzzle of mass is the very third secret to understanding the God particle and its role in revealing the universe's deepest secrets. It's a natural, ongoing process, a quiet testament to the universe's inherent design, holding within it the blueprint for all substance. Let the image of an incomplete cosmic blueprint, with a crucial missing piece, settle peacefully in your mind. This is the heart of our scientific quest, a journey that begins with the fundamental desire to understand what gives everything its very essence. Feel the quiet power of this unresolved mystery, knowing that the very questions you ponder are part of humanity's ongoing dialogue with the boundless universe. Rest deeply now, with the gentle hum of fundamental particles, silently asking for their missing mass, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler. As we continue our gentle exploration into the God particle, is it really the key to the universe? In our last quiet chapter, we confronted the profound mystery of mass itself, the gaping hole in the Standard Model that couldn't explain why fundamental particles have heft. Now, as you drift even deeper into your serene state, let us unveil the elegant solution proposed by brilliant minds, a subtle yet all-pervading influence that gives substance to everything, the Higgs field. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine the entire universe, not as empty space, but as being filled, permeated, and saturated by an invisible, omnipresent field. This is the Higgs field, a theoretical sea of energy that is believed to stretch throughout all of space, from the smallest quantum realm to the farthest reaches of distant galaxies. It's not something you can see or feel directly, yet its presence is utterly fundamental to your existence, and indeed, to the existence of everything around you. Think of this Higgs field like a vast, cosmic swimming pool, but instead of water, it's filled with this invisible, special kind of energy. Or, for a more gentle and familiar analogy, imagine a grand bustling hall filled with people. These people represent the Higgs field, always present, always active. Now, consider the fundamental particles, like electrons and quarks, as tiny celebrities trying to move through this crowded hall. Some particles, like the photon, the particle of light, are like a very shy, perhaps unknown, celebrity. They pass through the crowded hall with very little interaction. The people Higgs field don't pay much attention to them. They barely interact. Because of this minimal interaction, these particles experience very little resistance as they move. In the language of physics, they remain massless and continue to zip around at the speed of light. Other particles, however, are like very popular celebrities. When they try to move through the crowded hall, the people Higgs field swarm around them, eager to interact, to get close, to exchange pleasantries. This constant interaction, this stickiness with the surrounding field, creates resistance to their movement. The more they interact, the harder it is for them to move quickly. In the language of physics, this resistance, this stickiness, is precisely what we perceive as mass. The stronger a particle interacts with the Higgs field, the more sticky it becomes, and therefore, the more mass it acquires. This brilliant idea, independently proposed by several physicists in the 1960s, most famously by Peter Higgs, elegantly solves the problem of why fundamental particles have mass without breaking the beautiful mathematical symmetries of the Standard Model. It suggests that mass isn't an inherent, unchanging property of a particle itself, but rather a consequence of its interaction with this pervasive Higgs field. The field isn't giving mass in the way you give a child a toy. It's creating resistance, and that resistance is the mass. Imagine the sheer elegance of this solution. The universe, instead of needing to magically imbue particles with weight, simply blankets all of space with an invisible field. Particles that feel this field strongly gain substance, allowing them to slow down from light speed and bind together. Particles that don't, like photons, remain forever light and fast. It's a universal mechanism, a subtle cosmic constant that permeates everything. This interaction with the Higgs field is precisely what allows quarks to have mass and form protons and neutrons, which then combine with electrons, which also gain mass from the Higgs field to form atoms. Without the Higgs field, there would be no atoms, no molecules, no stars, no planets, no you. Everything would be a fleeting, massless blur, unable to coalesce into the solid, structured reality we know. The very solidity of your bed, the gentle weight of your blanket, the warmth of your skin, all are silent testaments to your particles' continuous interaction with this invisible, cosmic sea. Consider the profound implications. The Higgs field is not just an abstract concept. It is believed to be a fundamental component of reality, a continuous background hum of energy that gives substance to the universe. It's a silent, ever-present ocean, and all particles are either gracefully gliding through it with ease like photons, or gently pushing their way through it, gaining mass as a result of their interactions like electrons and quarks. This subtle, constant interaction is why your hand has substance, why the stars shine, and why galaxies exist. Imagine, as you drift deeper into your restful state, a vast, invisible ocean of energy, permeating every corner of the cosmos, from the most distant galaxy to the very space between the atoms in your body. Picture the tiny fundamental particles, gently interacting with this invisible sea, and through that interaction, acquiring the very property of mass that allows them to form everything you see and feel. This quiet, yet profound idea of the Higgs field is the very fourth secret to understanding the God particle and its role in revealing the universe's deepest secrets. It's a natural, elegant mechanism, a quiet testament to the universe's inherent design, holding within it the blueprint for all substance. Let the image of this invisible, all-pervading ocean of Higgs energy settling peacefully in your mind. This is the heart of the universe's substance, a journey that begins with the fundamental interaction between particles and a cosmic field. Feel the quiet power of this unseen connection, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of the Higgs field, granting mass to all things, guiding you towards a truly peaceful slumber. Welcome back. Peaceful Traveler. As we continue our gentle exploration into the God particle, is it really the key to the universe? In our last quiet chapter, we unveiled the elegant solution proposed by brilliant minds, a subtle yet all-pervading influence that gives substance to everything the Higgs field. Now, as you drift even deeper into your serene state, let us move beyond the invisible field itself and contemplate its observable manifestation, the elusive and fascinating Higgs boson, often referred to as the God particle, the very ripple in the cosmic sea that scientists sought for decades. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine that vast, cosmic swimming pool filled with the invisible Higgs field. This field is like the calm, deep water, always there, always ready to interact. Now, imagine a tiny pebble dropped into this incredibly still pool. The pebble creates a ripple or a wave that spreads outwards. The Higgs boson is precisely that it is a quantized excitation or a ripple in the Higgs field. It is the measurable, detectable manifestation of the field's presence. Think of it again with our analogy of the bustling hall filled with people, the Higgs field. The people are always there. But if a particularly popular celebrity suddenly enters the hall and tries to move through, the people, the field, naturally cluster around them, excited to interact. This clustering creates a noticeable lump or clump of people around the celebrity, a momentary surge in density in the otherwise relatively uniform crowd. This observable lump or clump of the field, this concentrated bundle of interaction, is the Higgs boson. So, while the Higgs field is everywhere and gives particles mass through its constant interaction, the Higgs boson is a specific particle associated with that field. It's not the field itself, but a particle that arises from the field's fundamental properties. Finding the Higgs boson was crucial because it would serve as the strongest experimental evidence for the existence of the Higgs field. If you can observe the ripple, it tells you that the pond, the field, truly exists. Without detecting the boson, the field would remain a powerful, but unproven, theoretical concept. The challenge of detecting the Higgs boson was immense. Why? Because the Higgs boson itself doesn't interact strongly with the particles that carry forces like photons, which mediate light. It's not something that glows or directly influences other fields in a way that makes it easy to spot. Furthermore, theoretical predictions suggested it would be incredibly heavy for an elementary particle, making it difficult to produce in particle accelerators. Its mass comes from its own interaction with the Higgs field, making it a unique, self-interacting particle. To find something so elusive and heavy, Scientists realized they would need to create conditions that mimicked the incredibly energetic environment of the early universe, where these particles could have originally been created. This meant accelerating other particles to unimaginably high speeds and smashing them together with tremendous force. The idea was that if enough energy were concentrated in a tiny space, it might briefly knock a ripple, a Higgs boson, loose from the all-pervading Higgs field. Imagine the decades-long quest to find this elusive particle. It was a true test of scientific patience, ingenuity, and international collaboration. Physicists knew roughly what they were looking for: a particle with specific properties predicted by the Standard Model. But they didn't know its exact mass, which dictated the energy required to create it. This meant building increasingly powerful machines, capable of generating the immense energies needed to potentially glimpse this fleeting ripple. The hunt for the Higgs boson became one of the most ambitious and expensive scientific endeavors in human history. Driving the development of colossal particle accelerators, the God particle nickname, while captivating and widely used, is actually a bit of a misnomer, and it wasn't coined by scientists. It gained popularity after physicist Leon Lederman used it as the title for his 1993 book. The God particle. If the universe is the answer. What is the question? He reportedly wanted to call it the goddamn particle because of its elusive nature and the difficulty in detecting it, but his publisher deemed that too provocative. The God particle stuck, giving the Higgs boson a mystique that sometimes overshadows its true scientific significance. It's not a divine particle in a religious sense, but rather a fundamental piece of the cosmic puzzle that explains how substance comes into being. So, the Higgs boson is the key evidence for the Higgs field. If the field exists, then its specific vibration, its ripple, should be detectable. Finding this particle would validate a crucial part of the Standard Model, filling that gaping hole in our understanding of mass, and confirming the elegant mechanism through which fundamental particles acquire their heft. It was the culmination of decades of theoretical work and experimental design, a silent, global effort to listen for the faint echo of a particle that holds the secret to substance itself. Imagine, as you drift deeper into your restful state, a vast, invisible ocean of energy, and scientists patiently waiting, building colossal machines, hoping to create a tiny, fleeting ripple within it. Picture that ripple, the Higgs boson, appearing for a split second, a testament to the elegant physics that gives everything you touch its very substance. This quiet, yet profound hunt for the Higgs boson is the very fifth secret to understanding the God particle and its role in revealing the universe's deepest secrets. It's a natural, elegant mechanism, a quiet testament to the universe's inherent design, holding within it the blueprint for all substance. Let the image of this elusive particle, a fleeting ripple in the fabric of existence, settling peacefully in your mind. This is the heart of the universe's substance, a journey that begins with the fundamental interaction between particles and a cosmic field. Feel the quiet power of this unseen connection, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of the Higgs boson, granting mass to all things, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler. As we continue our gentle exploration into the God particle, is it really the key to the universe? In our last quiet chapter, we contemplated the Higgs boson as the observable ripple in the cosmic sea, the evidence needed to confirm the existence of the Higgs field. Now, as you drift even deeper into your serene state, Let us journey into the heart of scientific discovery, to the colossal machine that made this profound detection possible. The Large Hadron Collider LHC, our planet's most magnificent, silent listener to the whispers of the early universe. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine the sheer scale of human ambition and ingenuity. To find something as elusive and fleeting as the Higgs boson, scientists needed a tool of unprecedented power. This led to the construction of the Large Hadron Collider LHC, nestled deep underground, beneath the borders of France and Switzerland, operated by the European Organization for Nuclear Research, or CERN. It is arguably the most complex and powerful scientific instrument ever built. Think of the LHC as a colossal circular racetrack for the tiniest particles. It's a 27-kilometer, about 17-mile-long tunnel, buried up to 175 meters, 574 feet beneath the surface. Inside this massive ring, incredibly powerful electromagnets, chilled to temperatures colder than outer space, even colder than the deepest reaches of the universe, close to absolute zero, guide and accelerate two beams of protons, the nuclei of hydrogen atoms. These protons are accelerated to speeds astonishingly close to the speed of light, about 90-10^991% of it. Imagine these two beams of protons, each containing hundreds of billions of particles, hurtling around the ring in opposite directions, completing over 11,000 laps per second. At specific points around the ring, within massive, cathedral-sized detectors, these two beams are made to collide head-on. These are not gentle taps. These are incredibly violent, high-energy collisions designed to recreate the conditions that existed just a tiny fraction of a second after the Big Bang. Why do scientists do this? Because, according to the theories of particle physics, fundamental particles like the Higgs boson are too heavy to exist stably at normal energies. To create them, you need to provide an immense amount of energy in a very small space, converting pure energy into matter, according to Einstein's famous equation. E equals mc2. The higher the energy of the collisions, the greater the chance of producing heavier, exotic particles that only existed in the fleeting, fiery moments of the early universe. The LHC's primary goal was to smash protons together with enough energy to potentially knock loose a Higgs boson from the all-pervading Higgs field. When these protons collide at almost light speed, they don't simply bounce off each other. Instead, their energy is so immense that it briefly transforms into a shower of new, fleeting particles, many of which quickly decay into other, more stable particles. It's like smashing two incredibly complex watches together at immense speed. You don't just get pieces of the watches, but fleeting glimpses of the raw, fundamental components and energies that made them up. The Higgs boson, if created, would be one of these fleeting new particles, quickly decaying into a signature of other, lighter particles. The real challenge, then, lies in detecting the Higgs boson. The Higgs boson itself is incredibly short-lived, decaying almost instantaneously into other particles. Scientists don't directly see the Higgs boson. Instead, they look for the subtle signature of its decay products within the colossal multi-story detectors that surround the collision points. These detectors are like giant, multi-layered digital cameras, meticulously recording every single tiny particle created in the collision, tracking their paths, measuring their energies, and identifying their types. Imagine poring over petabytes of data. That's thousands of terabytes, an almost unimaginable amount of information, looking for the faintest statistical anomaly, a slight bump in the energy distribution that matches the predicted signature of a Higgs boson decaying into other known particles. It requires years of meticulous data analysis, immense computational power, and the unwavering patience of thousands of scientists from around the world, all collaborating in this silent, shared quest. The signals are so rare, and the background noise so prevalent, that it's like trying to hear a single, specific whispered note in a stadium filled with roaring crowds. This incredible machine, the LHC, is not just about finding new particles. It's about pushing the boundaries of our fundamental understanding of reality. It's about recreating the conditions of the universe's birth to understand its very foundations. The patience, the precision, and the sheer scale of the effort involved are a testament to humanity's boundless curiosity and its determination to unlock the deepest secrets of existence. Imagine, as you drift deeper into your restful state, the silent hum of the colossal LHC, billions of particles hurtling through its superconducting rings, culminating in tiny, invisible collisions that briefly recreate the primordial fire of the Big Bang. Picture the dedicated scientists, patiently sifting through mountains of data, listening for the faint, elusive echo of a particle that holds the key to mass. This quiet, yet profound act of grand-scale experimentation is the very sixth secret to understanding the God particle and its role in revealing the universe's deepest secrets. It's a natural, elegant mechanism, a quiet testament to the universe's inherent design, holding within it the blueprint for all substance. Let the image of this colossal underground laboratory, silently probing the universe's smallest secrets, settling peacefully in your mind. This is the heart of particle physics, a journey that begins with the fundamental quest to understand what everything is made of. Feel the quiet power of this unseen connection, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of colliding particles, creating the very conditions of creation, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler. As we continue our gentle exploration into the God particle, is it really the key to the universe? In our last quiet chapter, we journeyed into the heart of scientific discovery, to the colossal Large Hadron Collider LHC, understanding how it recreates the conditions of the early universe to search for elusive particles. Now, as you drift even deeper into your serene state, let us arrive at the momentous day that captivated the scientific world, the detection of the Higgs boson, a culmination of decades of tireless effort, bringing a profound sense of relief and confirmation to the fundamental theories of physics. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine the thousands of scientists from around the world, all part of the enormous ATLAS and CMS collaborations at CERN, meticulously analyzing the vast streams of data pouring out from the LHC's high-energy collisions. For years, they had been sifting through the digital echoes of countless particle interactions, searching for the faintest whisper, the most subtle statistical anomaly that would signal the presence of the elusive Higgs boson. It was a search filled with anticipation, meticulous cross-checking, and the quiet determination that marks truly groundbreaking science. Then came the momentous day, July 4, 2012. Imagine the air in the control rooms at CERN, thick with anticipation. On that historic day, the scientists, with cautious optimism, announced that they had found compelling evidence for a new particle that matched the predicted properties of the Higgs boson. The signal was clear, statistically significant, and consistent across both independent experiments, ATLAS and CMS, which is crucial for scientific validation. It was a moment of profound triumph, met with a collective sigh of relief and exhilaration across the global physics community. Think of it like finding the final such crucial piece of a colossal, intricate puzzle that you've been working on for over 50 years. The puzzle is the standard model of particle physics, and the missing piece was the Higgs boson. Its detection confirmed the existence of the Higgs field, that invisible, pervasive sea of energy we discussed earlier, which is responsible for giving mass to fundamental particles. Without the Higgs boson, the Higgs field remained a theoretical necessity. With its discovery, it became an experimentally verified component of our reality. The significance of this discovery was immense. It wasn't just about finding another particle. It was about validating the very mechanism by which fundamental particles acquire mass. This meant that the Standard Model, the most successful theory describing the elementary particles and their interactions, was fundamentally correct in its explanation of why some particles are heavy and others are light. It filled that gaping hole in our understanding of why matter has substance, why atoms can form, and why the universe as we know it can exist. It was a cornerstone discovery, solidifying decades of theoretical work. This particle became famously known as the God particle. It's a captivating nickname, isn't it? It suggests a particle of ultimate importance, perhaps even divine intervention. However, it's important to gently clarify that this name was not given by the scientists themselves. It gained popularity after Nobel laureate physicist Leon Lederman used it as the title for his 1993 book. The God particle. If the universe is the answer. What is the question? Lederman himself reportedly coined the term because the Higgs boson was so incredibly elusive and difficult to find that it seemed goddamn particle. But his publisher thought God particle would be more appealing and less controversial. While the nickname has certainly captured public imagination, scientists generally prefer the more accurate term, the Higgs boson, named after British theoretical physicist Peter Higgs, who was one of the key figures to propose the mechanism for mass in the 1960s. The detection of the Higgs boson was a testament to the power of human intellect, collaboration, and perseverance. It involved thousands of scientists, engineers, and technicians from over 100 countries working together for decades. It required building a machine of unprecedented complexity and operating it at the very limits of technology. The patience and dedication involved, spanning generations of physicists, culminated in this singular moment of profound discovery. It was a quiet triumph, not with a sudden bang, but with the painstaking analysis of subtle data, revealing a truth about the universe's most fundamental workings. Imagine, as you drift deeper into your restful state, the joyous relief of scientists, their life's work validated by a tiny, fleeting particle. Picture the profound satisfaction of seeing a decades-old theoretical prediction finally confirmed by the most powerful machine ever built. This quiet, yet profound act of detection is the very seventh secret to understanding the God particle and its role in revealing the universe's deepest secrets. It's a natural, elegant mechanism, a quiet testament to the universe's inherent design, now confirmed by our own patient observation. Let the image of this moment of scientific triumph, a collective sigh of cosmic understanding, settling peacefully in your mind. This is the heart of particle physics, a journey that culminates in the fundamental confirmation of how matter acquires its very essence. Feel the quiet power of this unseen connection, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of the newly understood Higgs field, granting mass to all things, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler. As we continue our gentle exploration into the God particle, is it really the key to the universe? In our last quiet chapter, we celebrated the momentous detection of the Higgs boson, a triumph that confirmed the existence of the Higgs field and filled a crucial gap in our understanding of mass. Now, as you drift even deeper into your serene state, let us gently reevaluate the popular moniker, the God particle, and truly understand the real significance of this discovery, what it does explain and what it doesn't, clarifying its precise role as a key to the universe. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine the excitement that surrounded the Higgs boson's discovery. The catchy nickname, God particle, contributed immensely to public awareness and fascination, hinting at a fundamental, almost divine secret of creation. However, from a scientific perspective, this nickname can be a little misleading. While undeniably profound, the Higgs boson is not the God of all particles, nor is it the ultimate, singular key to everything in the universe. Its significance is more nuanced, yet equally beautiful. Think of it this way: the Higgs boson, and by extension, the Higgs field, is indeed the key to understanding why fundamental particles, like quarks and leptons electrons, possess mass. It successfully explains how these particles, which were theoretically massless in the Standard Model's original formulation, acquire their heft through their interaction with the all-pervading Higgs field. This was the specific, gaping hole in the Standard Model that the Higgs mechanism elegantly filled. Without it, the universe would be a massless blur of particles traveling at the speed of light, unable to form atoms. So, in this particular crucial sense, the Higgs boson is indeed a key to the universe, the key that unlocks the door to substance and structure in the microcosm. However, it's vital to understand what the Higgs boson does not explain. Its discovery, while monumental, is not the source of all mass in the universe. This is a common misconception perpetuated by the God particle nickname, mass of protons and neutrons. The vast majority of the mass of ordinary matter, the mass of atoms, and thus the mass of everything you touch, actually comes not from the Higgs mechanism giving mass to quarks, but from the immense binding energy of the strong nuclear force that holds quarks together to form protons and neutrons. Remember gluons, the force-carrying particles of the strong force. The energy tied up in the relentless interactions of quarks and gluons within a proton or neutron contributes over 95% of its total mass. So, while quarks get their tiny fundamental mass from the Higgs field, the bulk of the mass of a proton or neutron is a consequence of Einstein's famous ESMC2, where the energy of strong interactions manifests as mass. The Higgs boson gives the quarks their tiny starting weight, but the gluons and their interactions give them their incredible bulk when confined. Gravity remains unexplained, a major limitation of the Standard Model, even with the Higgs boson, is that it still does not incorporate gravity. The Higgs mechanism explains how particles acquire inertial mass resistance to acceleration and gravitational mass, the property that causes gravitational attraction, but it does not explain the fundamental force of gravity itself. The Standard Model lacks a graviton, the theoretical force-carrying particle for gravity, and it does not reconcile gravity with quantum mechanics. So, While the Higgs is a key to mass, it is not a key to gravity, which remains a profound mystery awaiting a grander unifying theory: dark matter and dark energy. The Higgs boson also does not shed light on the universe's most enigmatic components: dark matter and dark energy. These mysterious entities make up about 95% of the universe's total mass and energy, yet they do not interact with the Higgs field in the same way ordinary matter does, and their nature remains completely unknown to the Standard Model. The Higgs is a key to the 5% of the universe we can see and interact with, but the vast, unseen majority remains a profound, untouched mystery. So, while the Higgs boson is indeed a crucial piece of the cosmic puzzle, clarifying the origin of mass for fundamental particles within the Standard Model, it is not the only piece, nor is it the final answer to all of the universe's grandest questions. Its discovery marks a profound milestone, validating our most successful theory of particle physics and opening new avenues of research. It confirmed that the universe is indeed permeated by this invisible Higgs field, giving substance to the smallest constituents of matter. This confirmation has allowed physicists to refine their understanding of the universe's early moments and how it evolved into its present state. Imagine, as you drift deeper into your restful state, the subtle yet profound distinction between solving a crucial puzzle piece and completing the entire, boundless cosmic jigsaw. Picture the Higgs boson as a magnificent, glowing gem, illuminating a vital part of the universe, but surrounded by vast, unexplored territories of darkness like dark matter and dark energy, and fundamental forces like gravity that await their own elegant explanations. This quiet, yet profound clarification of the Higgs boson's true significance is the very eighth secret to understanding the God particle and its role in revealing the universe's deepest secrets. It's a natural, elegant mechanism, a quiet testament to the universe's inherent design. Now confirmed by our own patient observation, let the image of the Higgs boson, a confirmed piece of the cosmic puzzle, settling peacefully in your mind. This is the heart of particle physics, a journey that deepens our understanding of how matter acquires its very essence, while also reminding us of the vast frontiers that still await exploration. Feel the quiet power of this unseen connection, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of the newly understood Higgs field, granting mass to fundamental particles, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler. As we continue our gentle exploration into the God particle, is it really the key to the universe? In our last quiet chapter, we celebrated the momentous detection of the Higgs boson and clarified its real significance, understanding that it explains the mass of fundamental particles within the Standard Model, but not all mass, nor gravity, nor dark matter. Now, as you drift even deeper into your serene state, let us contemplate the vast, tantalizing frontiers that lie beyond the Higgs, the profound remaining mysteries of the universe that beckon scientists to continue their tireless quest. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine the Standard Model of particle physics as a brilliantly illuminated castle. The Higgs boson was the final, gleaming cornerstone, completing a crucial part of its magnificent structure. We now have a remarkably successful framework for understanding the particles that make up you, me, the stars, and everything we can see and touch, the ordinary matter that accounts for about 5% of the universe. However, just beyond the castle walls, shrouded in intriguing darkness, lie the truly immense mysteries, representing the vast majority of our cosmic reality. The two most prominent and perplexing of these remaining mysteries are dark matter and dark energy. Think of them as the silent, unseen architects and movers of the cosmos, yet completely beyond the grasp of the Standard Model, even with the Higgs boson, dark matter. Imagine looking out at the night sky, seeing countless stars and galaxies. We can observe how galaxies rotate, how they cluster together, and how light bends around them. When scientists calculate the amount of visible matter stars, gas, dust needed to explain these gravitational effects, they find a startling discrepancy. There isn't enough. The visible matter simply doesn't have enough gravitational pull to hold galaxies together or to explain their observed motions. This invisible, mysterious substance, which exerts gravity but does not interact with light or any other known electromagnetic force, is what we call dark matter. It's believed to make up about 27% of the universe's total mass and energy. The Higgs boson interacts with the particles of the Standard Model, giving them mass. But whatever particles constitute dark matter do not seem to interact with the Higgs field in the same way, nor do they fit into the Standard Model's framework. Its nature remains one of the universe's most profound enigmas. Imagine invisible cosmic glue, holding galaxies together, yet utterly undetectable by our usual means. Dark energy now. Imagine an even stranger force. Observations of distant supernovae have revealed that the expansion of our universe is not slowing down due to gravity, as one might expect. Instead, it is actually accelerating. This means there must be some unknown repulsive force pushing galaxies apart, gradually speeding up the expansion of space itself. This mysterious force, which permeates all of space and is believed to make up about 68% of the universe's total mass and energy, is called dark energy. The Standard Model has no explanation for dark energy. Its origin, its nature, and its implications for the ultimate fate of the universe are among the deepest questions in all of physics. Imagine a silent, invisible hand, gently yet relentlessly pushing the very fabric of space apart, faster and faster. These two dark components represent the vast majority of our universe, approximately 95% of everything that exists. The Higgs boson completes our understanding of the mere 5% of ordinary matter. This humbling reality underscores that while we've made incredible strides, the true key to the universe still involves vast, unexplored territories. Beyond dark matter and dark energy, other profound questions also lie beyond the Standard Model and the Higgs boson's purview. The nature of gravity. As we discussed, the Standard Model doesn't incorporate gravity. Physicists are still searching for a quantum theory of gravity that can unify gravity with the other fundamental forces. Is there a graviton, a force-carrying particle for gravity? How does gravity work at the smallest scales? These remain open questions. Matter-antimatter asymmetry. In the early universe, matter and antimatter should have been created in equal amounts. If so, they should have annihilated each other completely, leaving a universe full of only light. Yet, we live in a universe dominated by matter. Why is there this tiny imbalance that allowed matter to survive and form everything we see? The Standard Model doesn't fully explain this crucial asymmetry. The hierarchy problem. This refers to the puzzling discrepancy between the incredibly light mass of the Higgs boson and thus the weakness of the Higgs field and the much larger theoretical values predicted by other physics models. This naturalness problem hints that there might be undiscovered particles or forces interacting with the Higgs, or even extra dimensions of space that we haven't detected. These unanswered questions are not signs of failure. They are the vibrant frontier of new physics. The Higgs boson's discovery, while providing an answer, simultaneously opens up new avenues of exploration. It allows physicists to look for subtle deviations from the Standard Model's predictions, tiny cracks in its perfect facade, which might hint at the existence of these new particles, new forces, or even new dimensions. The LHC, and future, even more powerful particle accelerators, are designed not just to confirm existing theories, but to venture into these unknown realms, hoping to stumble upon the next fundamental discovery. Imagine, as you drift deeper into your restful state, the universe as a grand, infinite library. We have read and understood a few fascinating chapters, the Standard Model and the Higgs, but vast, unread volumes, dark matter, dark energy, quantum gravity stretch out before us, filled with unimaginable tales and profound secrets. This quiet, persistent quest for the unknown is the very ninth secret to understanding the God particle and its role in revealing the universe's deepest secrets. It's a natural, elegant mechanism, a quiet testament to the universe's inherent design, holding within it the blueprint for all substance, but also countless undiscovered wonders. Let the image of these profound remaining mysteries, the vast, unseen components of our universe, settling peacefully in your mind. This is the heart of particle physics, a journey that reveals the boundless frontiers of human knowledge. Feel the quiet power of these unseen connections, knowing that the very fabric of your world is alive with ancient, guiding principles and countless untold stories. Rest deeply now, with the gentle hum of unanswered questions, guiding you towards a truly peaceful slumber. Welcome back, beloved dreamer, for one final gentle whisper from the sleepy scientist. We have journeyed together through the subatomic realms, softly unraveling the profound mystery of the God particle is. It really the key to the universe. We began by contemplating the universe's earliest moments, when fundamental particles were massless, unable to form the solid structures of our cosmos. We then introduced the elegant map of fundamental particles and forces, the Standard Model of particle physics, and celebrated its incredible successes, while acknowledging its critical missing piece, the explanation for mass itself. Our exploration led us to the elegant theoretical solution, the all-pervading, invisible Higgs field, a cosmic sea of energy that gives particles their heft through interaction. We then contemplated its observable manifestation, the elusive and fascinating Higgs boson, the very ripple in that cosmic sea. Our journey took us into the heart of scientific discovery, to the colossal Large Hadron Collider LHC, the magnificent instrument that made its detection possible. We then celebrated the momentous detection of the Higgs boson in 2012, a triumph that confirmed the Higgs field's existence and filled a crucial gap in our understanding of mass. We gently re-evaluated the popular moniker, the God particle, clarifying its real significance, what it does explain mass of fundamental particles, and what it doesn't all mass, gravity, dark matter. And finally, we contemplated the vast, tantalizing frontiers that lie beyond the Higgs, the profound remaining mysteries of the universe, like dark matter and dark energy, that beckon scientists to continue their tireless quest. As you lie here, fully relaxed, perhaps feeling the gentle pull of sleep drawing you deeper. Let all these insights coalesce into a single, profound understanding. The Higgs boson, often called the God particle, is indeed a pivotal key to the universe. But it is not the only key, nor is it the final answer to all of existence's grandest questions. Its discovery marks a monumental achievement in human understanding, a testament to decades of relentless scientific inquiry, ingenious engineering, and global collaboration. It brilliantly explains why the fundamental building blocks of matter have mass, allowing them to form atoms, stars, planets, and ultimately, you. Without the Higgs field, the universe would be an insubstantial blur, unable to coalesce into anything recognizable. In this crucial sense, it truly is a key that unlocks the very substance of reality. Think of the beauty in this layered understanding. We have built an incredibly successful model, the Standard Model, that describes the fundamental particles and 3 of the 4 fundamental forces. The Higgs boson was the final critical piece of this puzzle, confirming its elegant mechanism for mass. This allows us to understand the world at its most microscopic level with astonishing precision. Yet, the very act of placing this final piece into the Standard Model's puzzle also illuminated the vast, dark, and still uncharted territories beyond its walls, the mysteries of gravity, dark matter, and dark energy, which together constitute the vast majority of our universe. This journey into the God particle is not just about learning scientific facts. It's about connecting with the very spirit of human curiosity and the endless pursuit of knowledge. It reminds us that every answer in science often opens the door to even deeper, more profound questions. The discovery of the Higgs boson was a magnificent endpoint for one chapter of physics, but it is also a powerful beginning for the next, propelling us towards new accelerators, new theories, and new ways of probing the fundamental nature of reality. It is a humbling and inspiring realization, knowing that we are tiny observers on a small blue planet, yet capable of unraveling the universe's most intricate secrets. There is a deep serenity in this knowledge, to understand the elegant processes that give everything its very substance, and to recognize the vast frontiers of discovery that still lie ahead, is to find a sense of calm in the boundless mysteries of the cosmos. It's to realize that the universe is a place of endless wonders, continuously revealing its secrets to those who are willing to listen patiently and explore with an open mind. The Higgs boson is a thrilling chapter in this grand cosmic narrative, a perpetual invitation to gaze into the unseen realms of existence with both humility and boundless fascination. So, as your mind quiets and your body grows heavy with peaceful sleep, take a moment to reflect on this profound connection to the universe's fundamental fabric. Imagine your dreams now, perhaps filled with the invisible hum of the Higgs field, or the silent dance of elementary particles, knowing that the very substance of your being is a testament to these elegant cosmic laws. This knowledge isn't meant to keep you awake with thought, but to lull you into a deeper, more profound state of rest, knowing that the very essence of your physical world is a story of magnificent, ongoing harmony. Let the quiet certainty of these scientific truths become a soothing lullaby. Feel the profound connection between your own stillness and the silent, majestic processes that constantly shape the world around you. The Higgs boson, the Higgs field, the Standard Model, and the vast mysteries beyond, all are part of this incredible, ongoing cosmic dance. There is no need to grasp or to strive. Simply let go and allow the universe's inherent beauty and profound logic to carry you into a peaceful, dream-filled slumber, guided by the gentle, everlasting story of the God particle and its role in the universe.